Hello everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. The topic which we are going to discuss today is inverse Fourier transform. This lecture includes finite inverse Fourier transform, infinite inverse Fourier transform. That is, we are going to in detail discuss about this inverse Fourier transform, both finite and infinite, problems based on inverse Fourier transform we are going to discuss in detail. The Fourier transform formula is capital F of x. That is, the capital F indicates or represents Fourier transform. This how we have to read. That is, Fourier transform of the function f of x. Otherwise, f of p. This way also we can integrate that Fourier transform notation, which is equal to integral minus infinity to infinity e power ipx into f of x dx. This is the formula for Fourier transform. Next, inverse Fourier transform. That is the difference between, easy way to remember, the function the f of x will be out. The Fourier transform will be the inside the integral. That is, we have to do the integral, that Fourier, the transform. So here we can find the difference between this and this. That is the f of x, it has come out. Here the Fourier, the transform formula which is written here. And this is with respect to x we are doing the integration. Here with respect to p we are doing the integration. These are the important points. If we remember, we won't get any careless mistakes. Next, Fourier Sine transform formula. That is, capital Fs, which denotes, if it is only f of x, we will read Fourier transform of the function f of x. But if s is there, then we will read Fourier Sine transform of the function f of x, which is equal to capital Fs of p. Fine. So now the integral, the function which is multiplied by sine px dx, we have to do the integration with respect to x from 0 to infinity. Inverse Fourier Sine transform formula is f of x, it has come out, and Fourier Sine transform, it is written inside the integral. So the Fourier Sine transform of the function into sine px, and we have to do the integral with respect to p from 0 to infinity. So these formulas, if you are noting, minus infinity to infinity, here minus infinity to infinity, 0 to infinity, here 0 to infinity. So these are all infinite. Now, Fourier cosine transform formula. The difference between Fourier sine transform formula and Fourier cosine transform formula is there s of f of x. This is Fourier sine. If it is Fourier cosine, in the place of s, we will replace s by c. It's a very easy way we can remember. That is how we are going to read this one. Fourier cosine transform of the function f of x equal to capital FC of p is nothing but the function which is multiplied by cos px dx. So inverse Fourier cosine transform. So this f of x, it has come out. Now this Fourier cosine, it has inside the integral which is multiplied by cos px, and we will do the integration with respect to p from 0 to infinity. So now so far we discussed that integral which is dominated minus infinity to infinity, otherwise 0 to infinity. So up to here, all the here two formulas, before we discussed 4 formulas. The total is 6 is infinite. The reason? Infinity is dominating. So they are infinite Fourier transforms. Now finite Fourier sine transform. So the difference is, here the difference, this notation is same, that is Fourier sine transform of the function f of x, capital F s of n. Just there we used the notation for the infinite p, here we are using n. But main thing what we have to remember, this is only the main reason. Infinity, so it comes under infinite, here only 0 to L. It is finite. So f of x is multiplied by sine of n pi x by L into dx. Whereas if it is infinite, we will write only f of x sine px dx. This is for infinite. For finite, f of x into sine of n pi x by L dx. So the difference between finite formula and infinite formula, we have to carefully note down. So the next one is, so the Fourier, finite Fourier sine transform we completed, from which we can get it inverse finite Fourier sine transform. That is, the f of x will come out. The Fourier sine transform will go. But here, the notation is summation. Here there is no integral. So that is summation from the n is going to take the value from 1 to infinity. 1 to infinity into 2 by L into sine of n pi x by L. This L is finite. That we have to keep it in our mind. Now, finite Fourier cosine transform, that is f, capital F, c of f of x, Fourier cosine transform of the function f of x, capital F c of n, which is equal to f of x, which is multiplied by cos of n pi x by L dx from 0 to L. That is, we are going to do the integration with respect to x from 0 to L. Inverse. So, inverse finite Fourier cosine transform. So, this f of x is coming out 1 by L capital F c of 0 plus 2 by L summation n equal to 1 to infinity. So capital F c of n, which is multiplied by cos of n pi x by L. N is taking the value from 1 to infinity. So finite and infinite, easy way to remember, sin px, cos px will be dominating for infinite, whereas sin n pi x by L or cos of n pi x by will be dominated for finite. And difference between the inverse, how to make a difference, we will do the integration with respect to p for the inverse. So we have to do the comparison study between the formulas, how we can avoid the careless mistakes. So if we do the comparison study between each formula where the changes are there. Now we will do the problem based on inverse Fourier transform. Find Fourier cosine and sine transform of e power minus ax and deduce the inversion formula. First, they are asking us to find Fourier cosine transform of this. Some function is given e power minus ax, and find even Fourier sine transform also. For both, deduce the inversion formula. That is, inverse Fourier cosine we have to find, inverse Fourier sine we have to find. So now the given function is f of x equal to e power minus ax, that's what it is given. We know it, the Fourier cosine transform, the formula is capital FC of f of x, otherwise or in another way, capital FC of p, which is nothing but the function which is multiplied by cos px. The reason is ours is Fourier cosine transform. If it is sine transform, we will multiply sin px. We will do the integration with respect to x from 0 to infinity. Now this f of x should be replaced by our given question, the function e power minus ax. Yes, we replaced it. That is, our f of x is taking the position of e power minus ax. That's what it is given in the question. Now, we have to do this integration. That is, the first one, e power, there is an exponential term. The second one is trigonometric function. So, one is exponential, one is trigonometry. So, how to do the integration? So, instead of doing integration by parts and all, the formula which is available for this integration, we can take it, we can apply the formula and easily we can come out. This is the formula. E power ax cos bx dx equal to e power ax by a square plus b square a into cos bx plus b into sin bx. The formula is written here. Now, according to our problem, this formula we will do the comparison. It is must we have to do, because in the formula it is e power ax is there. But coming to our problem, e power minus ax is there. That means in the formula a is there, in our problem a plus minus a is there. In the formula b is there, but our problem p is there. So we noted it is must before integrating, we have to do the formula and with the where we are going to apply the formula, what are the notations it differs? So A is taking minus A. B is taking P. Yeah, that we noted down. Now we are here we applied it. So e power ax, but according to our problem it is minus ax divided by a square plus b square. That is our problem, it is p. So it is p square. Here if you are noticing a cos bx, that is our a is minus a cos px plus b. Here b is there, but ours is p. So p sine bx, but ours is sine px 0 to infinity. Here e power minus infinity, the value is 0. E power 0, the value is 1. That we must remember these values. So now we can see it here. So we applied the upper, the value is infinity. So in the place of x, we have to substitute it because we did the integration with respect to x. That is the reason we are substituting in the place of x, the value infinity we substituted. So e power minus infinity, the totally, this has become 0. So 0 into this term also, no need to apply only 0 into anything, 0. So the upper one we got the value 0. This is formula minus. Next we will apply in this place. So now here x place we are going to apply the lower part is 0. We are going to apply in the place of x. Then e power 0. E power 0 we know it 1 by a square plus p square. Here minus a cos 0, the value is 1 plus p into sine 0, 0. That's what here it is written, minus a by a square plus b square, what we got it here. This minus becoming plus, so we got it a by a square plus p square. So Fourier cosine transform we got it. But they asked deduce the inversion also. That is the reason we are finding now. Here it is listed. Here it is written. Inverse Fourier cosine transform formula. This already just now we obtained the result. That is, this is the result. We Fourier cosine transform this f c of f of x. Our f of x is e power minus ax. This we did and we got this result. That Fourier cosine that we are substituting here. So 2 by pi equal to integral 0 to infinity. That value what we got the result into cos px dp because of this inverse Fourier cosine transform. Next, our question, the function is e power minus ax. That is only our f of x. This is our problem. The problem, our function is f of x equal to e power minus x. It is written here. So 2 by pi as it is, remaining everything it is written as it is. Next, 2 by pi, just we brought it to the left side, it has become pi by 2. So it is written here, pi by 2 into e power, yeah, this a also we brought it here. So pi by 2a into e power minus ax equal to the leftover integral. So we can see it 2a, it has come here. This pi, it has come up. Remaining the balance, it is written. So the Fourier cosine, the transform first we did, that we substituted in this place, the result, that is this one. And inverse Fourier sine formula means the function f of x will come out. The final result, we got it, pi into e power minus ax by 2a. Completely Fourier cosine transform and inverse Fourier cosine transform we completed. But in the question it is asked even Fourier sine transform also. So we are concentrating now Fourier sine transform formula, that is capital Fs of the function f of x. Fourier sine transform of the function f of x, it's nothing but capital Fs of p, which is equal to the function f of x, which is multiplied by sine px dx, and we will do the integral with respect to x from 0 to infinity. Fine. So it is written, our f of x is e power minus ax. We replaced by our given question the function e power minus ax. So e power, one is the function is exponential, another one is trigonometry. The formula which is available, e power ax into sine bx dx. So e power ax by a square plus b square into a sine bx minus b cos bx. We will do the comparison, this formula and our problem integral. We did the comparison when we obtained formula A, but in the problem the position is minus A. Formula, the position is B, whereas our problem position is P. Next, we are going to apply it now. E power ax, but here our a is minus a square, that is minus a the whole square, it's nothing but a square plus p square, because our b place p is there. A sine bx is the formula, our a is minus a, sine bx, sine px, formula minus, yeah, same minus, b cos bx, but ours is, our b is p, so p cos px, integral 0 to infinity. Now we will substitute. X place we are substituting. The upper, the value is infinity. So e power minus infinity, it's nothing but 0. The totally, the upper one is vanished. 0. Formula minus. The lower part is 0. So minus here, e power 0. The value is what? 1. 1 by, so I will write it here, 1 by a square plus b square. Here x place we are substituting. So minus a into here sine 0, it will become 0. This minus as it is, p cos 0, the value is 1. So we are getting minus p by a square plus p square. This minus, both getting positive. So p by a square plus p square, we got it, applying Fourier sine transform formula for our given function e power minus ax, the result is p by a square plus p square. But we can't stop up to here because deduce inversion formula also it is asked in the question. So, inverse Fourier sine transform formula. Inverse Fourier sine transform. The word inverse is there. Function will be out, left. Fourier sine, whether it is Fourier sine or Fourier cosine or Fourier transform, that will play in the role, in the integral role it will play. Now this Fourier sine transform of the function f of x, according to our problem, f of x is e power minus ax. We substituted, we derived and we got the result also. That is, this result we got it. We substituted in the particular place. Now f of x, it's nothing but, we know it, e power minus ax. This is our given problem function. This 2 by pi, that we push it to this left side. That's what it has become. Here the left side, pi by 2 into e power minus ax equal to 0 to infinity, the integral p by a square plus p square into sine px dp. We have to be very careful. Inverse integral with respect to p. We will do one more problem. Find inverse finite sine transform. That is, here the Fourier sine, the transform formula, Fourier sine, it has given, that is 1 minus cos n pi by n square minus pi square. The x lies between 0 to pi. So now we know it, this is the formula. F of x equal to 2 by L, summation n is taking the value from 1 to infinity. Here it should not come here, equal sign. The Fourier sine of the function, here this is the value which is given. So 2 by L, summation n equal to 1 to infinity, capital F S of n, sine of n pi x by L. The 2 by, we are noticing this L is replaced by pi because x lies between, according to formula, 0 to L. But according to our problem, it is 0 to pi. So L we replaced by, it has taken the value according to our problem, pi it has taken the value. Now this Fourier sine, the transform, it has given the value, just we substituted here. So sine of n pi x by L, it is there in the formula. But our L in the sense our problem, our question, it is 0 to L. So now the pi is, L is replaced by pi. Now this pi getting cancelled. Now 2 by pi, summation n equal to 1 to infinity. This is written as it is, sine of nx. So just we have to remember the formulas according to the problems. What is given L, we have to notice it. According to formula, it is L, but our L is maybe x lies between 0 to 4, 0 to 5, 0 to 10 or 0 to pi, whatever it is there. Here 0 to pi is there. We replaced that L by pi. Yeah, one more problem we will concentrate. Find the inverse cosine transform f of x if it is given the function, that is Fourier cosine transform, it is given x lies between 0 to 4. That means x lies between 0 to L is the formula. Our problem, x lies between 0 to 4. Yeah, we will write, yes, inverse finite Fourier cosine transform formula. So it is written the formula, that is f of x equal to 1 by L. F capital Fourier cosine of 0, 2 by L, summation, it is taking the value where n is taking the value from 1 to infinity. Fourier cosine transform, it is coming here, cos of n pi x by L. We will substitute. First, this we will find out the result, that is, this is capital FC of n. But we want it, FC of 0 we want it. That means wherever n here, we are going to substitute 0. The top first here we will substitute. That means cos of 0, we know it 1. So the numerator value, we got it 1. What about the denominator? The denominator here, we will substitute n plus 0. So 2 into 0, 0. So 0 plus 1, 1. 1 square also 1. So this particular value, we got it. FC of 0 is 1. L place what we have to substitute? Clear the picture. X lies between 0 to 4. L is taking the value 4. Yes. Substituted. This we have written. 2 is written as it is. Here L is taking 4. This as it is the summation. FCN, it is given in the question. Just we substituted. Cos as it is. N pi x as it is. Whereas L is taking, the position is what? 4. Here we should substitute the value also. 1 by 4 plus this we can simplify 1 by 2. The rest we can write it as it is, we can write it. Yeah, one more problem we can concentrate. Find the Fourier transform of f of x equal to a square minus x square if mod x is less than a. If it is 0, mod x is greater than a is positive. That is, a is greater than 0, it has given. Okay, mod x is less than a. That is, that x lies between minus a and a. If it lies between minus a and a, the function is a square minus x square. Remaining everything, whatever it is, the function is 0. What they are asking us to find? Fourier transform they are asking. Yes. And one more thing, hence show that integral 0 to infinity sin x minus cos x by x cube into dx equal to pi by 4. So first we will find Fourier transform. To deduce this, we will apply inverse Fourier, then we will obtain this result. Solution. So the Fourier transform formula is capital F of x. Now the notations are very clear to us. If it is Fourier transform of f of x, if it is like this, Fourier sine transform of f of x, if it is Fourier cosine transform of f of x. Yeah, coming back to this picture. Now capital F of x equal to integral minus infinity to infinity e power ipx into f of x dx. Now that f of x should be replaced by a square minus x square. Not possible. Why it is not possible? Because here x lies between minus infinity to infinity. Whereas here strictly they told the function a square minus x square, we can substitute for the integral where x lies between minus a and a. But here minus infinity to infinity. Then what to do? How to go? How to move forward this problem towards a solution? Yes, we can insert this minus a to a between this interval minus infinity to infinity. That is the only way we can move this problem towards the solution. Yes. Now minus infinity to minus a to a to infinity. We inserted in a correct way or not? Because if you do careless mistake in the beginning itself, entire thing what we are going to do will be, it will become waste. So we can cross check whether we inserted in a correct way or not. Easy way we can check it. Minus a we inserted, up, down it is there. A we inserted, up, down it is there. The remaining part is minus infinity to infinity. That's what it is there in the formula. Yeah, fine. Now, strictly it is given in the question. That is, the function a square minus x square is valid for the interval x lies between minus a and a only. Remaining whatever it is, the function is 0. According to our problem condition, the first integral is vanished. The reason? X lies between minus infinity to minus a. It is not possible. Second one is valid. It is matching with our given problem condition. The third one is also invalid. Doesn't exist. That is the reason the first integral and the third integral, the values have become 0. The second integral only exists. So now we will do the integral part. Now this integral, it is there. That is, one is exponential, another one is algebraic oriented. Now this algebraic oriented and combination with exponential, easy way we can do the integral. That is, first the algebraic part is written. A square minus x square. Then e power ipx. This we will do the integral. That is e power ipx divided by x coefficient. We want the coefficient of x. Leave that x. The remaining is ip. Easy way. We completed the integral. Yeah, put it here. Now, this sign is formula sign. Next, this algebraic part it is there, that we will do the differentiation. That is a square 0. Constant is the differentiation of constant is 0 minus x square. So minus x square, the integral is differentiation is minus 2x. That's what it is here. So this we did the differentiation. It is written algebraic part. This we did the differentiation. This we integrate and we put it. Again we are going to do integral, that is e power ipx. The integral we know it, e power ipx by ip. But already here one ip is there. That is the reason here ip the whole square. Fine. Next, this minus 2x, we will do the differentiation. Minus 2. Again this part, the exponential is, we can say it is towards integration we are moving. Algebraic part towards differentiation we are moving. This is the easy way of doing integration. At one stroke we can complete off. So now e power ipx, already ip the whole square is there. So ip the whole cube. So once again we can see it here. Algebraic oriented. Here the beautiful actually, the doubt actually. Why we have to take this algebraic oriented for differentiation? Then only the integral will come to an end. Because e power, if you have taken differentiation, it's prolonging, never-ending processing. But if you are taking the algebraic part for differentiation, so first we have taken as it is written. The second one, it has become minus 2x. The next it has become minus 2. The next minus 2, the differentiation is becoming 0. But if you are taking this exponential for differentiation, it is never-ending processing. So the algebraic oriented, the specific reason for taking differentiation, behind that reason only. Now, this exponential part, we did the integration. Again we did the integration. Again we did the integration. We stopped the processing here. Why we stopped it? Because minus 2, if you are going the next step for differentiation, it is becoming 0. So we did the integration. We completed it. So minus a to a. Yeah, before actually substituting this from minus a to a. Now, the simplification is there any negative signs. We will make it first to avoid the careless mistakes. Here minus into minus. It has become plus. Next plus into minus. Here minus. Now, remaining everything it is written as it is. Yeah. Now first we will apply the upper one. The upper one value is a. So in this place first a square minus a square. It has become 0. That's what it is not written here. Next, here we are going to apply. The first one it has become here 0 plus here 2a e power ipa by here ip square. That means I square p square. I square value we know it minus 1. Minus. That is the reason here it is kept to minus 2a e power ipa by p square. This term we got it. Next here we will substitute. So minus 2 e power ipa by I cube. I cube. I cube it's nothing but minus I. Because I square is I square into I. I square is minus 1 into I. It's nothing but minus I. So here minus I is there. P cube. If you are noticing, this minus is there. But 1 by minus I, the numerator, from the denominator we are bringing the numerator, it is becoming I. That's what here I is there. So the A job completely it is over. This is formula minus. Now we are moving to x place we are going to substitute minus A. So x place we will substitute now minus A. If you are substituting x place minus a, that is minus a the whole square again here. Minus a the whole square. That is what? A square. A square minus A square, 0. So the first one is 0 plus, here this place we are putting, x place we are putting minus A here. So 2 minus A, here e power minus IPA divided by this one. That is I square P square. That means minus P square. If you are noticing here, 2A e power, this minus, it has become plus. That is the reason here plus is there. This minus we know it already. That is a formula minus. It is not at all related to problem. Yeah, fine. Now, this term we will apply. So, minus 2 e power minus IPA by, this is minus IP cube. So, that's the reason here. Yeah, this minus, 2, 2. Here, P cube. But 1 by minus I, we can write it. We are going to from the denominator to numerator we are bringing. It is becoming I. So here we can notice it. Here I is there. So next, the last step what is there in the previous slide. It is written here. Now, this term as it is written. This minus we are taking inside. So this is also as it is. Now this minus into minus, it has become plus. Fine. Now we are noticing minus 2A by P square, the terms we are collecting. So we collected, so this term and this term. The leftover is this one. Yes, it is put here. This term, it is kept here. And this, the common 2I by P cube we collected and we kept it as common. So here the balance one is, here this one. Here it is there. Here the balance is, yeah, this one. It is kept. Now, this term it is written as it is. Now, 2, if you are noticing here, the plus it has become here minus. From here we have taken the sign out. Here minus sign. That is what this is become here positive. This is become negative because of this sign change. The previous step plus is that, but the next step minus is that. That is the reason here the inside the terms are also the sign changes are there. So the previous step it is kept here. Now cos theta, the formula is e power I theta plus e power minus I theta divided by 2. So what is our theta? This is formula, it is there in the theta. In the form of theta it is there. Cos theta equal to, it is in the form of theta. What about our problem in the place of theta? What is there? Yes, it is there in the theta place. IOK. Theta plus PA is there. And this 2 also we can make it here. It will become 2 cos theta. So 2 cos, according to formula 2 cos theta. According to our problem, our theta is AP. So 2 cos AP. This is written as it is. This also 2i we are bringing here. 2i sin theta. According to formula, according to our problem, it is theta is AP. Now capital F of x. So minus 4a by p square. So this 2 we are multiplying. So we got it minus 4a cos AP by p square. Now here noticing I into I it is there. So I into I square it's nothing but minus 1. Here minus is there, minus into minus plus. So 4 sin AP by P cube. So capital F of P equal to 4 by P cube This sin AP is written here. The AP, here P is not there here. We have taken the LCM, that is minus 4A cos AP into P plus here P. 1 minute. Yeah. Here P cube is there. Here P square is there. Common we have taken P cube. That is the reason it has become here 1 P it is there. Instead of A, we wrote it AP. Yeah. Now we will find the deduction. Inverse Fourier transform formula, because the question they asked us to deduce and to bring the result pi by 4. Yeah. So the inverse Fourier transform formula, which is 1 by 2 pi integral minus infinity to infinity capital F of P into e power minus IPX dP. It is written. So what we got is the Fourier transform, which is placed here. The next thing, this 2 and 4, we are getting cancelled. The 4 by 2, so it has become 2. Remaining everything, we wrote it as it is. The next step, everything it is written as it is, but this e power minus IPX, which is replaced by the formula cos PX minus I sin PX. Now, this into this complete part into cos PX, one integral. This complete part into minus I sin PX, one more integral. So it is divided into two integrals. The first integral and second integral, integrating between minus infinity to infinity, we have to do it. Before that, this function, that means this function, whether it is even function or odd function, that we will check it. Now, f of p equal to sin AP minus AP cos AP by p cube into sin PX. We are going to replace p by minus p. That is, wherever it is there p, that is going to be replaced by minus p. Yeah. We know it, the trigonometric sine of minus theta, it's nothing but minus sine theta, whereas cos of minus theta is cos theta. The changes will be there for sine, whereas for cos there is no change. Now, so here we are applying, that is p is taking minus p, then according to this formula minus sin AP, here minus a, but p is taking minus p. So minus a into minus p, it is becoming plus AP. For cos, if you change also, p has minus p, there is no change at all. So cos AP as cos AP only. The changes will come for sine term only. Yeah, here the change has been sin PX. It is minus sin PX because of this formula. Divided by P cube. We know it, minus P cube. The negative sign, power any odd number is there, compulsory negative only will come. Negative, any even number is there, compulsory it will become positive. So the negative now minus P. P is replaced by minus P. So minus P the whole cube, it's nothing but minus P cube. That's what it is written here. So the next thing, in these terms, minus we are taking out. So we have taken minus. Once we are taking minus, then inside whatever it is there, opposite signs will be. Yeah, here negative, positive, positive, negative, negative, positive, negative, positive. Fine. But we are noticing now, this is nothing but our given function. So, if you replace p by minus p, what we got it? Yeah, we got it this one. That is, the rule is x is replaced by minus x. We are getting the result minus into f of x. We can declare the function is an odd function. So it satisfies the odd function condition. So the second integral, what we focused, that is an odd function. Not only odd function, it is in the interval also. The integral is minus infinity to infinity. If the integral, that is the interval between minus infinity to infinity, and the function is also an odd, the integral is vanished. So now the two integral, the second integral doesn't exist. So we got it this one. The second integral has become 0. That is, this integral, it has become 0 because of the reason this we checked it. How we checked it? Put p by minus p. We satisfied the odd function rule plus the interval minus infinity to infinity. The total, the second integral has become 0. Now similarly, the same treatment we will give to the first integral. Yes, we have taken this complete function. We are going to replace p by minus p. So p by minus p we put it. Now f of minus p, we know it, sine of minus theta equal to minus sine theta. Cos of minus theta equal to cos theta. So sine AP, change will be there, minus sine AP. Here minus A, P is replaced by minus P, so that's what plus AP. For cos there won't be any change as it is cos AP. Here also cos PX, no change at all, cos PX, but P cube, it is minus P cube. Yeah. So we are noticing here the top one, we have taken the minus sign out. Minus sign if you are taking out, this is negative, it has become positive. This is positive, it has become negative. This, the remaining all written as it is. This minus, it has become plus. Now we are observing this is nothing but our given question. So that is P. If it is x is replaced by minus x, which is equal to f of x, then it is even function. If it is minus f of x, then it is an odd function. Yeah, fine. So now we got it. This is an even function and the interval minus infinity to infinity will be changed as 2 into 0 to infinity. So this is going to become 0 to infinity. The 2 is going to become 4. So the first integral, it has become. So we got it why the changes have become minus infinity to infinity. Suddenly the changes we brought in. Instead of minus infinity to infinity, we brought here 0 to infinity. And the 2 by pi also changed into 4 by 5 because of the reason this function is an even function in the interval minus infinity to infinity. Yeah, fine. So f of x we are writing. Now we have to satisfy. They gave some solutions to bring the answer pi by 4. Towards that we are now targeting a equal to 1. We are going to put, we know it, our f of x, it's nothing but a square minus x square. So in the a place we are putting 1, it has become 1 minus x square. This as it is everything written. Sin AP, it's nothing but a place we substituted 1. So sin P minus a place 1 we put it. So P cos P divided by P cube cos Px dx. Put x equal to 0. Why suddenly we are taking x equal to 0 and all towards the result to bring 1 minus, that is in the above 1, wherever x we are going to put 0. So here if you are putting, so here in this place we are putting, so the left side it has become 1 4 by pi integral 0 to infinity. Only x place we are putting sin P minus P cos P divided by P cube. Here is there x, cos 0 is 1 dP. That's what we got it. Yeah, it is written here the same. So the 4 by 5, we pushed it to this side, pi by 4. So we got it. This is the result. Pi by 4 result, we got it. What they are asked us to it. But the question is, integral 0 to infinity sin x minus x cos x divided by x cube dx equal to pi by 4. They told to deduce to bring this form. But ours, everything it is in the form of P. Very easy one. Replace P by x. Yeah. P by x we did. So pi by 4 equal to integral 0 to infinity sin x minus x cos x by x cube dx. Yeah, we will come to a conclusion. So the inverse Fourier transform, finite, infinite, the formulas we discussed and we did the problems also. The different types of problems we discussed. The inverse Fourier sine transform formula, it's nothing but f of x equal to 1 by 2 pi integral minus infinity to infinity. The Fourier will become inside the integral f of p into e power minus ipx dp. It's the notation. What are the notations? We have to keep in our mind very carefully. That is also in detail through this video lecture we discussed. And inverse Fourier sine transform, the formula also we discussed. Inverse Fourier cosine transform formula. This all the formulas minus infinity to infinity, 0 to infinity, again 0 to infinity. This all comes under infinite. And we discussed about finite also. Here L is dominating. And inverse finite Fourier cosine transform also we discussed, and different types of problems also we did. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.